Hello, this is our second demo video submission for Computer Science 4303. Purpose of this submission is to update on what we have achieved and fixed from the last buggy version, and let's get right into it. So first thing we would like to show is a version of our Hydralis fighting against, from a Zerg point of view, fighting against Terran on the 3-player map. So at the beginning of the game, we send our overlord over to scout, and we'll go over our scout logic in a moment. So as time goes on, seems like we got lucky with our scout. The overlord has successfully found the enemy base, and now if you look at the minimap, that is the trigger for our Zerglings to come to this location for a rush attack. And right away, you can see that the attack logic is we kill the enemy unit first, and then we went straight for the second marine that is being shown by the white lines of the targets by the Zerglings. Once all the marines are dead, we start tearing down the SCV and destroying the enemy's economy. So let's pause there for a moment. Let's move into our code base to see what we have changed and added. So the most important functions that for our code-based architecture is on each frame, the three most important information that is being found is in those three functions in our update enemy, update combat unit, and send combat unit. So let's look over the update enemy first. Oh, sorry. Inside of update enemy, we create a struct. Of enemy unit info where enemy unit info contains a last position and it contains the enemy ID. So we parse through the entire enemy unit, which is just a unit. Enemy units is just a unit set that contains all of the enemy units that we see in our field of view. We take their IDs, we put them in the holder, and we start parsing through. So if the get type is a worker, we push it into the worker. And there's a bunch of logic done here where we update the worker's last positions as well, and that is also done for the enemy buildings and the enemy units. So inside of this update enemy function, all we did is we look through every single enemy, depending on what kind of unit type it is, we push them into our corresponding vector, and if that unit that we're looking at on every frame already exists and is alive in our vector, it will not push back that the holder. And that's all the enemy update enemy function does. All this does is just updates the enemy units, parsing them into their individual little brackets. And this is useful for us when we are sending our attack. So next we'll take a look at, actually, is going to be the update combat units. So instead of update combat units, it's very similar to update enemies. So this is also where we update our Zergling vector and our Hydralis vector. As we create more units, we add them to the vector. However, the friendly unit vector, so the Hydralis and the Zergling, they are vector of my unit info, where my unit info is a struct that contains so it does contain our, just to show you. So my unit info just contains an ID and the Boolean value of if they are attacking or not. So once we get our, get the ID, we parse through the exact same way as before, and then we store them into the Hydralis vector, and then the Boolean value of attacking will be set in another function. Okay. Oh. And inside of our send combat units, this is where we played around with our numbers quite a bit. So essentially what's going to happen is that as long as our Zergling size is greater than or equal to a certain threshold, and this goes the same with thing with Hydralis, we will be changing the Boolean values of their attacking to true, and then we'll send them to attack. And in go attack, this is where all of our our attack logic is being done. So just to go over this very briefly, so we create three units called close worker, close building, and close unit. Every time go attack is called, one individual attacking unit is placed in is called into this function. So we're looking at the field view of what this individual Zergling that's being passed in as unit is attacking. So essentially, we look through all of our vectors that were updated from our update enemies function. As those are being updated, we parse through the enemy units, and then we find our closest unit to this particular unit that we pass in for attacking. Once we find the so there's a bunch of logic done here to find the enemy unit. Once we find the closest enemy unit, we will break out of this loop, and then we will look through the closest worker, closest building. And then in terms of attacking, we always attack the closest enemy unit first into the closest worker, and then we finish clearing off the buildings. So we take a look right here. So basically this is saying if there exists a closed unit that does not equal no pointer, and this basically just means that if there's something that is if that closed unit exists and is within our field of view, and then if the enemy unit vector if the enemy unit vector size does not equal 0, so that means there still exists an enemy in our vector, we will always attack the closest unit to our to the unit that's being passed in. Now, once all of the closed units, so once the enemy unit size becomes 0, or it doesn't necessarily become 0, because sometimes when close unit gets out of range, the close worker we normally end up attacking the close worker instead, which is intended. So we kill the units, then we move into killing the workers, and then we go into killing the buildings. And then once everything is dead, we will smart move to the enemy's location. Back to our video just to showcase this. So now now that marine spawn, we kill the marine first, and then we finish off the SCV. Another marine spawn, and killed our last Zergling, and now we move on into a Hydralisk. So we take a look right here. We create our Hydralisk then. We're going to start making a Hydralisk now, and then we normally go in patches of 10. We create a second hatchery just for additional larvae. So now our 10 Hydralisk has been created, and we will send them to attack. So we kill the fire bats here first, and then we start moving into their base. We see more enemy units. Kill those units first. Finish off the SCVs. So this is a big step from our last demonstration video, where our attack logic has significantly improved. And now that all the units are dead, we are proceeding to finish off all the buildings. So there's a little marine spawn there. We finished it off, and now we're just clearing off all the buildings. Once the buildings are dead, we will move to the enemy location. And that is all for this part. So in the second part of our demonstration video, we'll be showing a case where our Zerg on a 3-player map, how our units behave differently if the starting location that we first scouted does not contain the enemy unit. So eventually, this is where we make our first set of Zerglings. So you'll notice that when these first set of Zerglings are made, we do not have any idea. We do not know for certain on where the enemy is at this current time. So now these Zerglings are waiting on a queue from the scout to tell them where the enemy is. So they'll be waiting here for a little bit. Now once we go back to the scout, we'll speed this up just a little bit here. Oh, so now that we found that the Overlord has found that the enemy location does not reside in this one, this means that in this 3-player map, the enemy could only reside in one other possible location, which is shown by where my cursor is hovering. So let's go back to the code. So in our code, We have two functions that deals with the scouting. We have a function called scout at start, and we have a function called find enemy position. So let's look at find at start. So this function is called at the very beginning of the game. We loop through all the possible starting locations, and then we have a enemy position vector that we push back all the possible enemy spaces that they can reside on. We assigned our scout to be the overlord, so that's just done here. And then if it's a 1v1 map, it doesn't we don't really need to scout to find where the enemy is. We just know where the enemy is. Now, in the case where if the map is for 3 players, this is basically saying that if our vector contains a size of 2, that means that we're on a 3-player map. And then if one of the position is smaller than the other, the scout will move to the position that is less than the other position. So the purpose of doing this check here is to make sure that the scout is always going to the one that is the closest to us first. So this is just finding that position. We move to that position. And then once we found a position, we will just set the find E position flag to true. And that is how our Zerglin attacks are triggered. So going back to the video, our Zerglins are now rushing the other starting base. So once again, using the same attack logic, we kill all the Marines at the beginning first, finish off the SCVs, fight that Marine that just spawned, kill another SCV, finish off the rest of the SCVs, and we should see them attack their closest building as intended. So we'll notice that the first wave of Zerglings are dead. This is where we start developing further in our economy. We start making more drones, made our extractor, and now we have our Hydras. We make our 10, and we send them over to finish off the enemy. And that concludes the demonstration for part 2. So in part 3, we'll be going over what we did, the improvements we made, and what future work could be done. We significantly improved our attack logic, where originally had many situations where it was at idle or simply not attacking. And this is just a few of the bugs we fixed. We improved this logic by scrapping the entire O system we used. We got vector updating to work with the game and is able to store and live update all of the last position of a certain entity being seen. We also made sure the vector cleanup is done properly. One major obstacle was finding out how the gas structures interacted. We also made a scouting system that updates us on the enemy location to trigger an attack from our Zerglings, improving our portrayal of our entire build order on top of that. Assuming we had even more time, we will focus some attention on improving the microplay of our Zerglings and Hydralisks. One way of introducing microplay is implementing a surround movement on melee units such as Zealots. This will drastically improve the win rate of our ZVP in the early game. Another thing we can work on is when a Zergling is under a certain amount of health after being attacked by melee units, that Zergling will retreat back and other Zerglings will keep surrounding the enemy unit. And the Zergling that retreated back can attack another structure or go back in after the enemy melee unit is attacking a different target. We can also work on a Hydralisk micro strategy, where the Hydralisk will kite backwards during the CD of their attack interval, or kite inwards if we detect the enemy unit set is retreating. And lastly, we would like to deeply thank Dave for giving us a second chance on the submission for this project. Very much appreciated, and enjoy the break.